to do some housekeeping items. Attendees, I just want to remind you that you are all muted. I also want to let you know that this is recorded, so you'll be able to listen back to it. I'm going to put it on our Facebook page, on our YouTube page, and our website. And then as we're going, type in your questions. We're going to answer them at the end of the webinar. And just to let you know, this is going to be an interactive webinar. So we're going to be asking questions and you're going to be able to answer them. So please keep up or pay attention. So first I want to introduce Dr. Desirée Backman. She is the program director for UC Davis Institute for Population Health Improvement at the UC Davis Health Systems, and she's the president of California ReLeaf Board of Directors. So, Desirée.
Thank you, Mariela. Well, welcome everyone, and I'm very pleased to introduce Dr. ViVek Shandas. Dr. Shandas is a professor of climate adaptation and the research director for the Institute for Sustainable Solutions at Portland State University. He studies the effect of urban development patterns and processes on environmental health with specific attention to the assumptions that guide the growth of human settlements. He also serves as chair of the City of Portland's Urban Forestry Commission and is a principal at CAPA Strategies, a global consulting group that helps communities prepare for climate-induced disruptions. Today, Dr. Shandas is going to share some details about a new project which combines urban heat islands and community engagement. In my own work in population health improvement, I've seen firsthand how important community engagement and connection are to the health of our residents. In addition, as we work to manage the effects of climate change, we need to prevent heat-related morbidity and mortality and identify real-time solutions to improve the health of populations large and small. So without further ado, it is with great pleasure that I introduce to you Dr. Shandas.
Thanks, Desiree. Thanks, Mariela. Really a privilege to be with you. This is some work that's been culminating for many years, and I'm glad that we're having a chance to really work with practitioners and trying to advance the important work that's happening on the ground to address some of the population health concerns that Desiree was just describing. I'm going to go in and just jump right in and give you a little bit about my background and then lead into some general background about why this is an important issue to be thinking about, and then a project that I'd like to propose to you that we work on in California cities for the coming year in 2019, as well as moving into 2020 and 2021 ideally. So I'm going to jump right in and give you a little bit about my background. A little homage to my mother here, who just passed away a couple of weeks ago. Part of the reason I couldn't attend the California ReLeaf Summit or retreat that was scheduled a couple of weeks ago, there with my mother in the last moments of her life, and it was really great. And so I was born, just a little bit about me, I was born in South India, what I like to call the sweat belt, or the of the planet, and that's about 26 north to about 26 south. It's an area of the planet that is in many parts of this particular sweat belt are going to be really uninhabitable outside for parts of the day. And so this is going to be an area that we're watching carefully. We're of course watching the northern climes of the planet warm much faster, though the relative humidity and temperatures in this part of the planet are pretty unbearable. And it's kind of where a lot of my family lives now. So there's a personal connection for me in thinking about questions of urban heat as we think about the entire planet and how it affects parts of California, North America, and then different parts of the world. A little more about me. I was, after being born in India, after about 10 years, I moved to California, and I essentially grew up in Northern California in small town of Santa Rosa, which is not as small as it used to be when I was there, though has grown rapidly over the last few decades since I left. Though now that I spent some time in California, went to school in the Bay Area, college in the Bay Area, I really got a genuine sense for the landscape. I've traveled up and down the state, as well as many parts of the West Coast, and really have a genuine sense for the kind of climatological differences, which I really appreciate in the different parts of California. It really lends itself to the kind of work we're going to talk about today. So I consider this going from the sweat belt to the gold belt, given that it's a golden state. And so from here, I spent time in going to graduate school out in New York, from coast to coast, and then back to Seattle, where I really started to focus on questions related to our climate. And Rachel Carson quote that I really appreciate, that she said way back in 1965, says, "We stand now where two roads diverge, but unlike the roads in Robert Frost's familiar poem, they are not equally fair. The road we have long been traveling is deceptively easy, a smooth superhighway on which we progress with great speed, but at its end lies disaster. The other fork of the road, the one less traveled by, offers our only chance to reach a destination that assures the preservation of the earth." This is really what's motivated me to kind of go back east to New York to spend time in grad school, and then back out to Seattle, where I've can take the boy out of the West, but apparently can't take the West out of the boy. So came back to Seattle, where I finished my PhD, and then have been in Portland, Oregon, working all along the West Coast since. And that kind of gives you at least a little sense of my geography and some of the biases I may bring in terms of the work that I'm doing. So to kind of get into this, since I was born, the readings on the planet's carbon dioxide have been just really phenomenal to watch. When we see it over a 10,000 year period, we see a hockey stick that happens in the last about 150 years. And then in the last roughly about 50 to 70 years, we've seen these carbon dioxide concentrations increase on a planetary level. And this is important because these carbon dioxide and other greenhouse gases, as they're generally called, link directly to a lot of the climate challenges we face, particularly because there's a very clear link between trapped carbon dioxide in our atmosphere and the forcing that does on temperatures, and kind of the blanket effect that carbon dioxide and other greenhouse gases create on the planet, forcing a great deal of temperature increases that we'll be getting into at the local level, and talking about how that plays out. Many scholars have thought about this and said, you know, we're actually at a point where humans are affecting the entire planet. And generally we know of this era as the Holocene, which is where we see large growth of impacts of human species worldwide. We see the creation of modern culture through our experience and moving in different parts of the world. We see lots of architecture, design, arts, and writing all emerge during this Holocene period. And really humans have now covered every part of the planet. And we really are at a real interesting turning point, and many call a great transition right now. So this is the broader context in which some of this work is happening. Others are really pushing forward to this idea of going from the Holocene to the Anthropocene, which is specifically focusing on the fact that humans are now a geologic force. In other words, they are having a measurable and profound impact on the planet as we know it. Historically, it's often been volcanoes or earthquakes or movement of continents that have had these geologic effects, or even asteroids hitting the Earth that have had this geologic effect in theory, though now there's a very vocal and pretty fastly growing group of people that are calling this the Anthropocene, because we're seeing vast changes to our climate, our biodiversity, changes in nutrient cycling across the planet, changes in stratospheric and atmospheric conditions, acidification of oceans. The amount of water that's been diverted and consumed is rapidly changing because of human activity. We've seen land use change, air pollution, as well as chemicals that are more and more present in our troposphere and our atmosphere. So we're seeing all of these things come together, and that's really getting people to wonder, what effect is that having? And what I want to talk to you a little bit about today, and the projects that are ongoing, are thinking about notions of how this plays out at the local level. We've seen in 2018 that temperatures were roughly 1.8 degrees Celsius warmer than the 19th century. We're seeing July 2018 in California was the hottest month ever recorded. The most recent climate assessment confirms humans' role in flooding and heat waves, and that a whole new science of climate attribution has been born as a result of trying to link these global patterns of greenhouse gases and what's happening across the atmosphere to very local effects of flooding as well as heat waves, which is what I want to get into today. So let me pause there and ask you a question, and you have a way to respond on a poll here. So I'm going to go ahead and ask the first question to see if it can jog some of your thinking in linking these kind of global patterns to local levels. So let me start with a softball for you and just start with this question of, do the concerns of global climate change seem too big for any one person to make a difference? What's your feeling about this question? What's your general sentiment behind this? Let me give you a minute to respond here. Do the concerns of global climate change seem too big for any one person to make a difference? It's one of the big questions being asked by several people around the world about how can an individual make a difference. So what's your sense of this? So it looks like we're about 50-50 on this one. Okay. Good. Well, that was very interesting. We have about a 50-50 showing on that. And so I'm going to try to keep going with another question that I want to pose to you that has 5 different answers, so a little less of the 50-50 possibility here. So I want to go to the next slide, which has another poll question. And Mariela, can you move it to that next slide with the second poll question? Don't seem to, there we go. So what recent events do you see as directly linked to global climate change? So wildfires in California are clearly on people's minds and thinking about the relationship between recent events and global climate change. So I'm going to go into a little bit more detail. So that was really helpful to learn. And I'm going to go ahead and keep going here and try to see if I can get it to the next slide. The next slide really has a summary of I'm going to keep trying here, but the next slide has a summary of the reasons why these questions are important to our group. We're really trying to, I'm a principal of a group called Climate Adaptation Planning and Analytics, CAPA, and we're really trying to understand 3 dimensions of this relationship between global climate change and climate dysfunction, as I like to call it, and very local effects. And the 3 things that we do, there we go. The 3 things that we work on are engaging communities and describing and localizing climate-induced hazards. So we have our flagship program, which is the Urban Heat Watch program, which we engage communities. I'll be talking about that at length today. We also develop online analytical tools for examining scenarios of adaptation actions, such as, for example, expanding urban forests. And then we also work with communities to do prioritizing and trying to build capacity at the local level for addressing some of these. I'll be spending more time on the first 2, the Heat Watch and the Urban Insights components of CAPA today. We've really found these to be very effective in terms of supporting the community. Oops, have a little slide switch here, but our team is relatively small, but we're pretty nimble and able to work in various capacities. We have graphic designers and outreach folks, software developers, and geospatial analysts, data scientists, and we kind of work at a very local level with the communities that we engage. We have multiple projects ongoing right now with supported by NOAA and potentially by CalFire, as I'll be talking about in a minute here, and we're kind of trying to dig deeper into some of these local effects and describe hazards. So to get into CAPA's Heat Watch program, one of the things that we are really excited about is working with folks in California to conduct a series of these community science and urban heat assessments. As you might know, as the sun shines more often in California than in other parts of the Northwest, the West Coast, the shortwave radiation is really packed with energy, and it comes down and affects different features on the landscape in different ways. So we see, for example, buildings absorbing potentially a lot more of that and re-releasing it as long wave radiation, and then trees really absorbing that solar radiation and evapotranspiring it, as well as producing sugars along with water and other nutrients. And so what we see is different features on the landscape affecting or interacting with solar radiation in different ways. And so one of the things that has been coming out is that much of this urban heat work has been done with satellites and sensors on satellites that measure that long wave radiation coming off of surfaces. And while that might be helpful, what we're often faced with is the satellites are really only getting at the surface temperature. So that could be on the rooftops or the roads or the lawns or open space parks, and we're not actually getting at the experience of the ambient temperatures, what people experience as they're walking around a region or even a neighborhood. And so what we're really proposing here is to collect much more ambient temperatures through engaging communities. And we found this to be effective for a variety of reasons, which I'll talk about in a minute. We start off by we've developed a simple temperature and humidity sensor that mounts onto a car. We've had people also mount these on bicycles, and we create a series of what we call polygons or areas around a particular city. In this case, it's Washington, D.C. on the map in the upper right here. And that allows us to essentially collect hundreds of thousands of individual temperature and humidity measurements as we gather together a group of people. They all have these different sections of the city where they go out and do basically data collection for an hour in the morning. So 6 a.m. they go out for an hour and collect temperature and humidity readings. In the afternoon, they go out and do it again, 3 p.m. And then in the evening at 7 p.m. And one of the advantages of this is that you can really see a full day profile of what an area looks like over time. And the communities that are participating in this are often very, very charged, lack of a better word, with the actual collection of the data. We do the analysis of the data, and then we give it back to them in a series of maps of showing the distribution of temperature and humidity, or even thermal comfort, which is another way of thinking about it, the heat index for different parts of a region. And so as people are more and more engaged in these types of actual community science efforts by collecting the data, understanding how it's done, looking at different features on the landscape, and then interpreting the results in the form of maps, we really see a lot of uptake and a lot of receptivity in trying to understand the relationship between how we build our urban regions and then what might be amplifying some temperatures and what might be ameliorating some of the temperatures. And so through this campaign that we've now done in about 12 cities, and we're going to be doing another 12 more this summer, we end up with a series of maps such as the one on this slide, which is the city of Portland, Oregon, where we see at a 1 meter resolution the differences in different parts of the city. So the redder the area, the warmer it is, the bluer the area, the cooler it is. And there's freeways and some arterials that have been put on here. And there's for those of you familiar with this particular city, there's a river running essentially through it called the Willamette River. And we see right adjacent to the Willamette River a lot of industrial land as well as downtown that in the morning at 6 a.m. are really hot. In the upper part towards the right is the airport, and that remains very hot. So what we're seeing is these areas are absorbing a lot of the solar radiation in the daytime and not letting go of it all during the night. as opposed to the farther areas in the east side of this particular image, what you'll see is a lot more blue, which suggests that those areas are in the morning relatively cooler in the ambient environment. So if I go to the afternoon, we see that the red areas actually change quite a bit throughout the city, and you see that there's specific parts of the city that are starting to light up in red and getting much warmer, such as the industrial northern parts of the city industrial area, the train yards, the airport, and some of the green spaces are retaining some of that cool. The whole west side or the left side of the map is mostly blue, and that's largely due to a very large park called Forest Park, as well as a lot of very highly canopied neighborhoods in the southwest of the city. Then when we go to the evening, we see even further shifts in some of these hottest areas, and we really start to see, for example, roads emerging as a very big kind of collector of heat, and in the evening we're really seeing those as highlighted. And there are many residences that live alongside these roads, and so what we're really trying to think about is how does this heat then overlay with who's living in these hottest parts of the city, what infrastructure might be there that's vulnerable to these heat waves. And so what we're really starting to get at is a full diurnal or a full day profile of how heat changes from one part of the city to another throughout the day. That allows us then to understand what is it on the landscape that actually starts to give us the factors that most mediate neighborhood temperatures, and we can break it down to about 6 things. And those really fall out by thinking about the amount of tree canopy, so that's any vegetation that's 3 meters or taller. We look at the percent of vegetation on the ground, that's the grasses or shrubs that are 3 meters or smaller, small trees, for example. We've come up with a measure called tree canopy density, and that's using LiDAR data. We're actually able to think about how much biomass there is in the trees and seeing whether that plays an effect. And it turns out in our case, it really had a pretty significant effect in terms of explaining the temperatures at a very local level. The height of buildings seem to really play a role, as well as the volume of the building. So that's kind of these big box stores adjacent to sometimes adjacent to large parking lots. Kind of they interact to really absorb a lot of the heat. Again, at that very local 1 meter level. And then building height, we notice places that have a lot of difference in building height. We speculate that it might allow for greater amounts of circulation, air circulation in those areas, which we know from at least a thermodynamics point of view affects the local temperatures as well. So this work has been now going on for several years, and we've done this campaign, engaging communities, putting sensors on cars and bicycles, and collecting hundreds of thousands of temperature humidity points. And last year, for example, we did it in Washington, D.C., and we brought together a group of people. We mounted a series of sensors on these cars. They sit on the passenger side of the cars. You can see this a high school student essentially mounting it on the car and then driving around. It's a small little system, relatively compact, easy to deploy. And what we are seeing is, for example, this is a output of our Washington, D.C. Campaign that we did last summer that National Geographic took really to heart and is publishing this out in June, which will be a very interesting way to kind of broaden the discussion about how different features on the landscape really affect our local temperatures. So this will be coming out in July next month. If you're into National Geographic, I'd encourage you to pick up a copy and take a look. It's a well done piece, relatively pithy and easy to understand the relationship between the built environment and the distribution of heat. Let me pause there and see if I can do this again with a poll and simply ask the question, do you expect to see, oops, it's a typo, similar differences in temperatures in the area where you live? So do you expect to see similar differences in temperatures in the area where you live? we've seen roughly a difference of about 17 degrees. And so let me pose this to you and see if see if you would anticipate similar results in your neck of the woods. Okay, so that's overwhelming. Okay, so it sounds like it's a pretty overwhelming yes in your area. I think we have seen this now pretty consistently across most of the regions we work, all the regions we work. One interesting thing is that satellite sensors, when they're doing this, they don't pick up on humidity, which isn't necessarily a big case in the West Coast compared to other parts of the world, though as we see temperatures generally increase around the world, we're seeing models suggest that even places that are relatively temperate now will be seeing an increase in absolute as well as relative humidity in the coming decades. So that's something we want to just keep an eye on, in addition to just temperatures. So I'm gonna, oops, boy, there we go. I'm gonna try one more question. Let's say you consider something like this in your region. If you wanted to do something like an urban field campaign to be able to bring some attention to this at a very granular level like we can provide, I'm curious which stakeholder groups you might consider participating in an urban field campaign in your region. Would any of these groups potentially be communities that you would want to engage if you were to do something like this in the area you live? So let me open up this poll as well and see if you respond.
So the majority is local university researchers and urban forestry groups.
Yeah, great, I see that. Okay, so it looks like local university researchers, urban forestry groups, and to a certain extent, environmental justice groups are really the core makeup of many of these potential participants. And that's pretty consistent with what we've seen so far. We've really seen a lot of uptake by urban forestry groups because of the direct link to relationship between trees and the cooling effect that they provide. And that's pretty compelling for a lot of communities to really be able to use these data to then advance a number of urban forestry goals. So one of the big questions that come up is, so what? And so the next step from conducting these campaigns is to kind of create these maps, which you can see throughout the day, differences. And then what we want to do is we've done work where we've overlaid the relationship between sociodemographic groups and the hottest places in the city. And so what we found, for example, in some of the places where communities living in the hottest parts, in this case of Portland, we see communities that have less formal education, limited English proficiency, we see higher racial diversity in those areas, as well as a lot more extreme poverty in those areas. We found, for example, in a paper we published recently that communities that identify as white are more likely to have central AC, while communities with children are less likely. So this has differing effects, we've also noticed, on Asian and older adults, and it's likely to be able to keep them from being able to access heat refuges. A number of public health, county public health open cooling centers and things like that, and we found, for example, in other work we've done, such as this, where we took the city and looked at the blue areas in the bottom right are places where they're essentially walking distances from cooling centers that the county has set up. And we really overlaid those on top of the hottest areas of the city. And we found a pretty clear link between where the cooling centers were being placed and who might need them the most. And the county's taken up some of this work to really rethink how they're distributing and engaging the communities that might be disproportionately affected by heat. So the other piece of the so what is, what can we do? And I work quite a bit with land use planners and designers, and one of the things that's come up is the question that planners and designers ask us is, well, we're getting a lot more people in our region. Can we increase housing density while maintaining or reducing pre-development temperatures? So that's the big question that they had posed to us several years ago, and we started in on this process by providing them with essentially a result of some modeling work that we did that I just want to touch on briefly. We took, for example, a large lot neighborhood like the one you see on the right side of the screen here, and we said, what happens if those 16 units, meaning those 16 homes on that block, were to change to 64 units? So a lot of multifamily residential development were to be established there, and we were to change the physical structure of that area. How is it that that would essentially affect temperatures? So what we did was we took a computational fluid dynamics model called EnviMet, and we were able to simulate that particular scenario. So what we did is we took that block, made it look exactly like it was, and then simulated differences in terms of what would happen to that block. For example, I'll just show you a quick kind of extreme version of what we did on that block. We took that area, call it a high canopy neighborhood, and we looked at what was the effect of greening that would have. So in the base case, in the far left, upper left here, you see a digitized image of a block, city block. Then we essentially eliminated all the green spaces on that block, and we ran a simulation, Sim 1. That's pretty much all asphalt, so we're clearing all the trees. And then in the far right, Sim 2, we added trees wherever we could in the public and private areas of that block. And what we can do over a period of a day is simulate what would be the temperature throughout the day in that place, and we validate this with a local sensor that we've placed in that location as well. And so what you do is you simulate that, and you can see that there's a difference of roughly about 13 1/3 degree difference when you go from that base case to taking out all of the vegetation in that area, and really would end up almost being about a 15-degree difference if you were to even remove that vegetation versus looking to add a little bit of additional vegetation. So this is a one scenario, or a couple of scenarios we started to look at in terms of extreme effects. And then we wanted to figure out whether on a rezoning to higher density in the same block, rather than going those extreme cases, whether rezoning would actually allow us to look at different design considerations for that particular area. And what we did was take the same block, and we were able to simulate 6 or really 7 different types of development. So we cleared the block in terms of the simulation. We were able to put the gray, which is building. So you notice the gray and the green is essentially greenery, both in terms of small shrubs, grass, as well as trees. And we tried these multiple different plans. So plan 2, 3, 4, 5, 5B, 6, 6B, and then 6S. And the difference between 6B and 6S is that 6 essentially creates this perimeter block model, and 6S, with 6 having trees right in the middle. With 6B, we essentially put asphalt, typical kind of parking lot design where you have a multifamily residential and lots of parking around it and within it. This is very commonly done, kind of the status quo, if you will, for multifamily residential in many parts of the West Coast. And then in 6S or 6 Super, we actually did the similar design to 6, except we lightened the roads adjacent to the building, and we wanted to see what role that would have on temperatures as well. And in the bottom right is the base case that we started from. And in this graph that I put up now, we'll see the difference in temperatures that are average temperatures for that city block. It varies from place to place, you might imagine, though the average temperature change for that entire block essentially plays out to these following kind of rainbow graph of all these different colors representing different plans, and then their heights representing how much effect they had on the change in Celsius. So in this case, Celsius about 3 is roughly about what is that, about 7 degrees Fahrenheit change for that 6B, which is the asphalt. That's an increase of about 7 degrees Fahrenheit. And what was remarkable was that we actually found that with the 6S design, where we lightened the roads, and in addition to what we did to Plan 6, keeping trees and green space in the center of this higher density development, we were actually able to reduce the temperature by about roughly 4 degrees Fahrenheit, or 1.75 Celsius. And so we were actually able to show the planners that this was something that was possible, where you can increase the density while thinking about temperature or very local experience of that ambient heat. So that's a really big moment for us where we said, aha, it's really about how we think about greening our places, which led us to this second piece, which I'll just bring to your attention briefly. It's an online tool that we set up at branchoutpdx.org, where once we completed these urban heat campaigns, we'd gone forward with looking at these design scenarios, the community came to us and said, hey, how do you identify the specific locations where you might be able to expand green infrastructure? And so what we came up with was an online tool that has a series of filter controls that allow you to look at the amount of current canopy, the urban heat index. We had some data on air pollution that we were able to bring in. We can really vary those filter controls, whatever is relevant to the local community, though we were able to bring in environmental, social, as well as land use considerations, and we can go down to the parcel level to identify where adding or expanding green infrastructure could have a direct effect on temperature as well as air pollution. So this was a way to systematically focus on communities that have been historically underserved with green infrastructure, recognizing that urban heat may not affect everybody the same, and moving towards finding ways to get shade and other kind of strategies for identifying communities that could be inequitably affected by rising temperatures. So that was a tool that we built to be able to identify areas that might be affected disproportionately. We went further to actually create another tool that allows you to actually look citywide. What would happen if you added additional greenery, changed, for example, that 6S design? What if we were to take that 6S design and apply it across the city, and as opposed to doing it in leaving it as it is? And so we created this little filter tool for municipal planners and designers to look across the city, how if you kind of sweep this center line back and forth, you can see that the difference sometimes is upwards of 20 degrees, over 20 degrees Fahrenheit difference in terms of the mitigation strategies one can use at the very local level versus letting things happen as they do and potentially paving over an area. So this was a way to at least get attention of municipal planners for what design and urban development, how design and urban development might interact with the last thing I want to say just really briefly is in the city of Richmond, we worked with Groundworks RVA, which is a national nonprofit, Groundworks, and we were able to look at where ambulances went for heat-related illnesses. And what was really remarkable was the urban heat vulnerability index on the left side of the screen really overlays very well with the ambulance responses, the Richmond ambulance responses on a really hot day in Richmond. So that was one of those moments where we said, wow, the urban heat island is really driving a lot of this concern, as well as calls for ambulances during acute heat and respiratory related events. So this was in response to some communities saying, prove it that heat is really a health related challenge. And so we were able to actually do this analysis to show that it was in effect. And finally, a lot of this, the question of so what, a lot of this has made its way into urban sustainability and resiliency plans in communities around the country. And so every community that we've worked with, we've seen active uptake of these data into various planning efforts. And so that allows us to really figure out a way to localize the effect. So I want to just pause there again and do one more quick poll with you to see if there might be additional considerations you have for conducting something like this perhaps in your community. So I want to ask the question to you, what additional considerations in the modeling exercise would help you consider the role of trees in urban development? What are additional considerations in the modeling exercise that would help you consider the role of trees in urban development? Species of tree, okay. Okay, and we'll go, it sounds like species of tree was very helpful, or was very important in this, so it's something for us to really consider as well. The next question, the last one that I have for you is, does your region currently have planning efforts underway that take into consideration the results from similar heat campaigns? So are you thinking about this at all? Okay, let's call it. Okay, about 46-54. Okay, well, great. I'm really thrilled to see that there are many communities that are actually have planning efforts underway to take into consideration some of these heat-related. This is going to be an increasingly challenging issue for communities to deal with, and trees are often play the front line in much of this work. So for us, the next steps are really just to integrate. We have other work on financial dimensions of this, human health dimensions, so we're really looking to integrate a lot of those dimensions. We're looking for to develop online tools and evaluating the impact of trees lost and gained. So if an area loses a lot of trees like we saw in the simulation, are we seeing resulting increases in temperature? What if a big development goes in and there's a lot of change in a neighborhood? What can we track in terms of that effects of that development on the very local experience of temperatures there? As well as looking at policy levers locally. We've seen some incentives. Boston just put forward an incentive program to give developers additional credits for putting in various heat-related mitigation strategies when they're putting forward a new development. And so we're seeing those policy levers really start to emerge, and it's very early in this work. So we're just trying to get a handle on what's happening in what different place, in what places. And then finally, we're launching. I'm delighted to describe that we're doing this Heat Watch program. It's likely going to be underway in 3 communities in California in 2019, and then we're starting to look for communities who want to do something like this for 2020. On average, it takes about 1 day to collect all of the data. It takes some time to set up the communities to collect the data. It takes about a couple of weeks, maybe even a month, to prep communities to collect the data. Then we distribute the equipment, collect it, and then we're able to analyze and turn it around relatively quickly for quick uptake of the results. And so we have opportunities available for 2020. I'd be happy to chat with you or check in with you about possibilities for your region to do something similar. We have a little starter kit that we provide to communities to be able to do this, and we have a pretty tight end-to-end process to make this happen. And we've really seen urban forestry be one of the biggest benefactors to these kinds of campaigns, because they have a direct role to play in terms of cooling, as well as improving the overall local conditions at the neighborhood as well as city block level. So with that, let me kind of just sign off and give you some contact information in terms of at least an email and a website for you to check out some of this work, and be happy to answer any questions. If you have any comments of the work, I'd be happy to field those as well. We have just a few minutes left, so I want to be kind of as tight as we can.
So ViVek, are you able to see the questions?
I'm not able to actually go down into that tab. My mouse doesn't seem to be showing up on my screen for some reason.
Okay, so the first one is, how does putting in solar panels into parking lots compared to putting in trees?
Right. So one of the things, solar panels in parking lots is interesting. We haven't tested this per se, though. Solar panels reduce I do know that solar panel effectiveness is reduced when the local temperatures are increased. So what you're really trying to do is create ideal conditions for the solar cells to be able to capture the radiation from the sun. And when temperatures get up too high, for example, in a parking lot, which has been one of the primary areas where we've seen very high amplified temperatures, as you might experience as you're going shopping on a hot day, the solar panels actually reduce their effectiveness. So what you would ideally want to do is, instead of a trade-off of solar on parking lots versus trees, you might actually want to figure out ways to get solar in places that are actually that are filled with trees or green infrastructure of some kind, so that you're actually able to cool the solar panels while giving them access to that sunlight and allowing them to work a little more effectively, while also allowing the trees to evapotranspire and cool the surrounding area. So there's trade-offs there that I think are really just now underway, and we have a couple of projects I've seen that have tried to evaluate the effects of integrating solar with trees. But generally speaking, trees do a lot for cooling parking lots, though we need kind of larger clusters of them and spread out in order to be able to really see that significant reduction in temperature.
The next question is, where can you buy the measuring devices that you used in citizen science projects?
Right, so these are actually things we developed in-house. We've been spending the last 5 years essentially testing out various different forms of instrument and equipment, and I'm not in the job of selling this equipment. We have a program where we rent these out for periods of upwards of a month. We can rent them out, and that's essentially the best we can do at this point. They're effective in terms of, or they're precise in the sense of they get to 1/10 of a degree. So you can get at, for example, 98.1 or 97.3. You can get to the 1/10 of a degree precision, and we've calibrated it with National Institute of Standards and Technology NIST certified thermometers and humidity sensors as well. And so they're all kind of up to par, and we've been really testing this in a lab environment to make sure that the sensors are able to capture accurate temperature humidity readings at every 1 second interval. And we're working on a second version where we're actually able to send the immediate measurements to a cell tower, which then send it to our server, and you can see real-time temperatures as people are driving or biking around and collecting the data. And so that's in the works now, and we'll have those ready to go probably in about a month or so.
Next is, who is the intended user audience for the tools you produce at branchoutpdx.org, or how has it been received? Are you getting the usage level you were hoping to?
Yeah, so Branchout has been a really much wilder successful platform than I ever imagined. It was a very experimental design where municipal foresters came to us and said, you know, we need something to be able to more strategically identify locations where we can plant trees, and we can be less responsive directly to the loudest voices who say, I want trees, and more to those communities that have historically not engaged with us. And so this tool was a way for municipal foresters to be able to identify neighborhoods and specific parcels, even median strips in front of parcels, median strip between the sidewalk and the road, where planting can happen. And so it started with a focus on municipal foresters and city folk, though what's happened is it's really taken off with the nonprofit communities, like the Friends of Trees groups, that have really taken it to be more strategic about where they're going about identifying places they're going to plant trees, working with those communities to see if they want trees or not want trees. And it's really playing out as a rapid assessment tool. And there's for example, if you go do the filters, you get down to an individual set of parcels, you can download the addresses as a CSV. And we've seen people go on a door knocking campaign to ask people if they want trees in their front yard, trees in the median strip. And if they say no, then they keep moving on. They say yes, they give them information about where they can get free trees or at least subsidized trees, and help them with that process. So we've actually seen it be far more effective than I ever imagined, and we're actually building these now for multiple cities around the country, and I'm hoping to build about 3 of them for communities in California this coming year.
So the next question, what communities are you targeting for your 2020 work?
Well, 2020 is still in the works. NOAA, National Oceanic Atmospheric Administration, has come to us and said they want to do this campaign for every city in the country. And I said, oh no, because that sounds really hard. Though what's happened is we've actually seen a lot of receptivity. This year we're have about 12 cities we're doing across the country, and next year I'm hoping to ramp that up to about either between 25 and 30 communities, because we'll be able to move this at scale next year, given the fact that we're able to put all the webinar and kind of instructions through these webinars, as well as videos online. We ship equipment out, the rental equipment, we ship it out. We have a little user agreement that we have people sign, and then we essentially go forward. So right now, 2020 has about 6 cities signed up, and we're looking to probably build that out for another 24 cities if people are interested. So I'm really, part of the reason I really wanted to engage with you all as forestry folks is that's the community we've seen tremendous interest in, with not only these tools, but these campaigns that can show very granular results in terms of heat distribution.
Next, we have a very technical question. Could you explain why you divided urban trees into 2 categories, above 3M and below 3M, in the urban heat study? Also, except buildings, height, and volume, did you see any impacts from the percentage of impervious surfaces as a whole on urban heat at the city scale in your work?
Yeah, so about the tree height, the reason we did 3 feet and below, or 3 meters and below 3 meters, is because we use LiDAR data, which if you were to use LiDAR data for things that are below 3 feet, you run into major computational bottlenecks, because what you end up seeing is hundreds, I mean millions, literally hundreds of millions of individual objects that create a lot of noise in the data. So when we can just identify those trees that are 3 meters or above, and look at everything else that's below that's alive. For example, we can use high resolution nape imagery to describe what's going on below that 3 meter level. And so that allows us to be a little bit more effective in terms of dividing it up. And in terms of that's a logistical piece more as much as it is kind of just a pragmatic way to computationally run billions of calculations on individual points. The second piece is about building height and volume and impervious surface. We found a direct correlation between the presence of buildings and impervious surface. So in areas that had lots of buildings, we saw a very high likelihood of impervious surface. And so in our model, we chose to go with the buildings and the building volume rather than the impervious surface, because we were seeing marginally better model results when we were bringing in the building descriptions as opposed to the impervious surface descriptions. So that's at least 2 responses to that.
The next one is, I live in an oak woodland. My homeowner's insurance has not been renewed due to wildfire concerns. How can you get insurance companies involved?
Oh boy, that one is really hard for me to answer. That's not an area that I've got a lot of expertise. The insurance industry I think that's far more complicated to try to get into. I don't know if I would be the best person to be able to answer that. I could fake it, but I really don't want to do that on this particular question. So I'm gonna kind of yeah, I'm gonna have to pass on that one. Little outside of my area of expertise.
Okay. The next question is, you mentioned CAPA may have potential projects with CalFire. Would you elaborate on that?
Yeah, so we're in the process of working with California ReLeaf and CalFire to identify 3 communities. And I think Cindy Blaine, who's the executive director of California ReLeaf, may have mentioned this at the retreat in Los Angeles recently. And we're really trying to focus in on 3 communities, and that is to begin this and to show proof of concept for communities across California. But to show this in LA, we have specific areas in LA that we're focusing on. San Bernardino is another area we're looking at, and then Oakland and Berkeley, Alameda County is another area we're focusing on, and we're going to be doing it in addition to Sacramento. So we actually have 4 altogether now that I'm counting. Sacramento, LA, San Bernardino, and Oakland, Berkeley, Alameda County area. And so those are going to be 4 campaigns that will happen this summer. That's partly supported by CalFire, partly supported by U.S. Forest Service, that we're going to be able to go down and or at least we're going to be able to collect these data and then build also these online 3 Branchout PDX type tools. I'm going to call them generically Branchout tools for these LA, San Bernardino, and the Alameda County, Berkeley, Oakland area. And so that's going to be, we're very close to it. I can't quite say it's confirmed, but we're very close to being able to advance that this summer.
The next question, are there specific tree species that are more effective in improving the tree canopy or absorbing carbon? This is more of an arborist question, but I don't know, do you want to answer it?
No, I don't have a good response. I have a student in my day job as a professor. I have a student who's looking at this exact question right now using LiDAR data, and we have at least some level of species differentiation that we're looking at. But off the top of my head, I would not be able to answer that very accurately.
Okay, and then here's a relevant question. Do you coordinate with volunteers yourself, or do you work with local groups to do that?
We work, so far all of our work has been with local groups. We want to kind of work with those communities. First, we don't go to any community we're not invited to go into. That's rule number 1. Second rule is we work only with communities that have a real vested interest in trying to engage communities that have historically not been engaged. And so we have to be bringing in an equity lens to this work. And we work with organizations like environmental or climate justice organizations. We work with urban forestry groups that are trying to expand urban canopy, trying to conserve urban canopy. We work with city municipalities, sustainability offices, climate action plan offices, and we kind of try to build capacity with those groups through kind of trainings, and then they work with their community collaborators to be able to bring together individuals or groups to then go out, collect data, come back, and then run these kinds of webinars to discuss the results and see where they might be effectively applied. So we all exclusively, to put it just really briefly, we work with the organizers in specific places to be able to then run these campaigns.
Okay, just 2 more questions and then I'll cut it off.
Okay.
What months, this one is from San Bernardino, what months did you pick for your heat mitigation project in San Bernardino?
Oh, I see. We don't have an exact date yet. The ideal, what we look for is essentially 3 conditions. One is that we have volunteer or community collaborators or community scientists, as we call them, ready to go. So we have a group of people that have identified and said, hey, I can help you with this project. I am willing to drive. We remunerate them for their time. So we look for, so to get a group of people, then we have a really clear, dry day. So we want a day that doesn't have any rain, that really diffuses the heat signals that we pick up on from the different surfaces. And we want a day that's in the 90th. Third thing is we want a day in the 90th percentile of historic average temperatures. And so in San Bernardino, off the top of my head, my hunch is that's probably around 95 or so. Something above a 95-degree day Fahrenheit would probably be a go day for collecting temperatures. So my hunch is probably August, or nowadays even getting to September and October for some parts of Southern California. So that's essentially where we're looking, is August into September for San Bernardino, all depending on how well the Cindy and California ReLeaf can get all the pieces together to make this happen. I'm really excited about that.
Okay, just one more question, and then I believe this isn't more of an arborist question. Knowing what tree species seems like it would be vital so that invasive species don't get planted. Trees that require extensive amount of waters aren't planted, and then knowing how big, what kind of the root system certain trees will have or could impact plumbing infrastructure. Is this something you will be doing more research on or could provide more information on?
Yeah, so we've actually connected with a few folks at in a couple of different places, but Oregon State University and then Yale School of Forestry are 2 places where we're asking these questions about what species of trees would be most effective in the urban, very densely developed environment. and we're getting a variety of different, a lot of different feedback. Though at this point, our tool, like our Branchout tool, doesn't have that level of detail. It tells you generally location. It's much more of a spatial tool than necessarily a species or a selection tool. And so the next, I think, I don't know, version 2 or version 3 would likely have more of that kind of information, so that people can go use the local kind of tree planting list, or if you have local tree ordinances and things like that, that you can build that into the actual selection of the species. I couldn't agree with you more, though, that these multiple considerations about what you're actually putting into the ground, like right tree, right place kind of thing, is so central to kind of pointing people in the right direction. But we're working on that. I'm hoping in the coming years to be able to kind of layer on some of that into our online tools.
So that's all the questions we have. Thank you, Dr. ViVek Shandas, for staying 12 minutes over time, and thank you all the attendees who stayed longer than needed. I hope this webinar was very useful, and that's it.
Okay, great. Thank you so much, Mariela, and everyone for joining and the wonderful questions. I'm really keen to continue working with you all.
Goodbye, everyone.